Now, some of you may already be a little bit familiar with graphing, and this is going to be one of the last sections and chapters that we cover. We will cover a little bit about polynomials as well, and that'll be included in your final. So this will be included in your final, as well as the homework we're going to go over. So we're going to look at 3.1 today, and we're going to talk first about the basics of graphing. Now, when we go to graph equations, we have to plot points, and we work in a two-dimensional system. And what I mean by that is we've got a Cartesian or coordinate plane. Sometimes it's called the Cartesian plane, named after the French mathematician René Descartes. And so when we look at this Cartesian plane, we've got right here in the middle where they intersect, that is 0, 0. And that's called your origin. Now, positive x goes this way, negative x goes back to the left, positive y goes up, negative y goes down. So this is our Cartesian plane. Let me brighten that screen a little bit here. Okay, so that's what we're going to be working with. Now, when we use this, we're going to be plotting points, and when we look at points, they're called ordered pairs. Now, ordered pairs have two variables, x and y. And x is always listed first, y is always second. And x is the left and right. Y is going to be the up and down. Okay, so we've got x and y there. Now, the first thing we're going to learn how to do, and it's going to be probably a review for many of you, is we're going to learn how to plot ordered pairs. So I'm going to list some out, and we're going to plot the ordered pairs. And we'll just plot these. How about 5, 2? How about minus 3, 4? How about 0, negative 2? And one more, how about negative 4, negative 5? So I want us to plot these ordered pairs. Now, what does it mean when I plot the ordered pairs? We're not going to connect them together. We're just going to put a dot where they belong. Now, when we go to work with these, what do we know? We know that the x is listed first. Y is second. So these all go x and y. Now, the x is the left and the right part. Y is going to be the up and down part. So when we look at plotting these ordered pairs, we have our coordinate system here, and we just count from the origin. So we're looking at 5, 2. So that's going to be over 5 units and up 2 units. So that's going to be right there at 5, 2. What's the next point going to be? The next point's going to be negative 3, positive 4. So it's negative 3. So that would mean we would go back 3 units, and then we go up 4. So 2, 3, 4, and that's our new dot right there at minus 3, 4. The next one is at 0, negative 2. So 0 is right here. Negative 2 is down 2. So right there is 0, negative 2. And the last one is negative 4. So there's negative 3, negative 4. And down 5. So 1, 2, 3, 4, 5. So that's minus 4, minus 5. So that's how you plot those ordered pairs. Now, are we connecting them together? No. Whenever I use the word graph, that means we connect them together. If it just says plot the points, then all you do is plot them. Now, what we can do next is we can look at an equation and we can determine if something's a solution. Now, if I give you an ordered pair, if it's a solution, when we plug the values in, then the sides will equal. So I'm going to give you an ordered pair and an equation, and you're going to tell me if this is a solution. Is this going to be a solution to this equation? Well, what makes it a solution? It's going to be a solution if I plug the values in and the sides equal, if it comes out to be true. So this is your x and this is your y. So when I plug my values in, that gives you 2 times 3 plus 5 for the y. And does that equal 11? Yes, because 2 times 3 is 6. Plus 5 makes it what? 11. The sides are the same. If the sides are the same, then it is a solution. Is everyone okay with how I did that? Just plug the values in, and if it's true, then it is a solution. Let me start another one. I'll make sure everyone has the new homework packet here. Turn this buzzer off as well. Okay. So that one was a solution. Now I'm going to give you one that is not a solution, and we'll see why. So let's see if this one is a solution. Is minus 2, positive 5, a solution to 4x plus y equals 12. Now, if it's a solution, what should happen? The sides should be the same, right? So let's plug in our x value and our y value and see if it comes out to give you 12. If it comes out to a different number, then it is not a solution. So that would be 4 times negative 2 plus 5. Well, that's supposed to equal 12, right? But 4 times a negative 2, well, that's a negative 8. And negative 8 plus 5, that's negative 3. And does negative 3 equal 12? No. So this is not a solution. Is everyone okay with what's a solution? So what does it mean if I give you an ordered pair and I ask you if it's a solution to an equation? You have to be able to plug it in and make the sides match up. So that's the difference between a solution and something that is not a solution. Now we can also complete ordered pairs and we can graph a line. To graph a line, we only need 2 points because we're going to be connecting them together with a ruler or a straight edge. So we need at least 2. We can have more than 2 points, but we need a minimum of 2 points. So I'm going to give you some ordered pairs, and we're going to complete them and graph. So I'm going to give you 2 of these. And let's plug in negative 1, and we'll find the other value for y. And I'll give you one where we plug in a y value here. So let's go with, how about positive, or sorry, how about negative 2? Okay, so here's our ordered pairs. All right, and we're going to try to complete the ordered pairs here. So we're going to plug these values in, and we're going to see what we get out. Okay, so if I plug these values in, let's see what we do. On this one, this is our x value. Now, what are we missing? We're going to be missing the y value. So this is your x. We need to find the y value. So when I plug in the x value, what do we get? We get y equals, because we're finding that, 5 times a negative 1 plus 10. All right? And 5 times a negative 1, that's a negative 5, plus 10, well, that gives you y equals now what? Positive 5, doesn't it? So there's that component, which is your 5 there. Now, we need two different ordered pairs. So what about this one? The next one. Well, what value am I going to be plugging in? I'm going to be plugging in the y value. Now, they do not always come out to be whole numbers. If they come out to a fraction, that is okay. When we plot that point, we just kind of get the closest point to it. So if we have to plug in a negative 2 for y, right, that gives you a negative 2 for the y value. And that's going to be 5x plus 10. We'll move that 10 over with subtraction. And now we've got negative 12 equals positive 5x. We'll divide by our 5. And what is x now going to be? Well, x is now going to be negative 12 over what? Positive 5. So we found the x value by plugging in the y value. Now, when we go to plot a fraction, we get the decimal equivalent and we try to see where it belongs. Okay, so we're going to get the decimal equivalent and we're going to pick the closest point to it. So let's try to plot these 2 points. Okay, so these are the 2 points we're going to be plotting here. Put it up a bit so we got more room to graph. Our first point, well, where is it? It's at -1, positive 5. So -1, positive 5 would be back 1 unit. There's -1. And then we're going to go up 1, 2, 3, 4, 5 units. So it's going to be right there at -1, positive 5. All right. Now, what about the next one? Well, the next one got a fraction, but let's get the decimal equivalent. That way we can plot it. Now, what's the decimal equivalent of -12 fifths? Choose a calculator. Okay, -12 fifths. What does that come out to give you? That comes out to give you a -2.4. And what do we know about that -2.4? Well, that is in between -2 and minus what? 3. So we just kind of guess about where it's at. It's about halfway in between the two. So -2.4 minus 2, well, that would be back about 2.5, so right about there, down 2 units. And that's going to put that dot, well, let me get it in the right place. That's going to put that dot right about there. And that's going to be my new point at -12 fifths, comma, -2. Now, I have 2 points, and what can I do with these 2 points here? I should be able to connect them together with a what? With a ruler or a straight edge. And that's going to make our new line here. So let's make sure we have this all down here. Make sure we got everything plotted correctly. If it all looks right, because we went back about 2.5, and then we went down 2, so that makes that point right there. When we connect them together, it's going to make a line. And that line looks like this. So it's going to be similar to that. They don't have to be perfect graphs, but they're going to be a line, and you just connect them together. Now, when you do your homework, it's going to be a lot easier for you because, look, you've got a grid. Okay, all of your homework, you have grids where you have to graph them. Let's try another one. And then we'll look at one that just has one variable. So I'm going to have you complete the ordered pair. I'll make it, in this case, in a table and graph. So complete the ordered pairs and graph, and I'll give you a new equation here. We'll come up with something that's pretty simple to work with. How about y plus 2x equals, how about 3? So I'm going to give you a table. I want you to complete the table here. And let's make sure it works correctly. So how about we put in a y value of 1. We'll find the correct x value that corresponds with that. We'll plug in an x value of 0. We'll have you find the corresponding x value. Okay, and let's see. How about we do another one here, because we'll use another point. How about we plug in -2 for the x value, and I'll have you find the y value. So this is another way of presenting the exact same type of problem we just did. Now we're going to have to do each one individually, and we're going to fill in the empty boxes here. So each one is going to have to be done, and then we'll connect them together to make our graph. So on our first one, what's our y value? Y value is 1. We want to find the missing part. So we're going to plug in y equals 1. And if I plug in y equals 1, we get 1 plus 2x equals 3. Okay, we're going to solve this for the missing variable, which is x. So we're going to move that 1 over. So 2x equals 2. We'll divide by our 2. And what does x now equal? X equals 1. So that's going to go right here. We just do each individual blank. Now, what about the next one? The next one, what are we plugging in? This is our x value here. We're going to plug in 0. So we're going to plug in x equals 0. And if I plug in x equals 0, that gives you y plus 2 times 0 equals now 3. 2 times 0 is 0. So y plus 0 equals 3. So y equals now what? 3. There's that piece. What about the next one? What are we doing for the next one? Well, the next one, we're going to be plugging in a -2. So let's plug that in. And we've got y plus 2. Now watch your signs here. Times a -2 equals 3. 2 times a -2, well, that makes it a -4. And we'll plug in, we'll solve this, so we'll add our 4. And what do we now get for our y value? Y is now what? 7, isn't it? Okay. Let's make sure we're all on the right track here. Does everyone see how I plugged the values in and got our answers? That's all you have to do. Now, all these came out to be whole numbers, and most of the time when you plot points, they're going to be whole numbers. I did want to do one fraction one, just so you'd see that sometimes you do end up with fractions, right? But most of the time it's going to be whole numbers. Now, to graph a line, what do you need? At least 2 points. Now, you can have more than 2, but you need at least 2 points because all we're going to be doing is connecting them together with a ruler or a straight edge. Now, if they make some kind of curve, you made a mistake. They are going to be a straight line. It can be a vertical line, horizontal line, or in most cases, a diagonal line. So that's what this one's going to be, as a diagonal. Now, it's as a table, so let's rewrite these as ordered pairs. So my first one as an ordered pair would be 1, 1. My second one would be 0, 3. And my last one is going to be -2, 7. So I just took my table and I rewrote them as ordered pairs. Remember, this is your x and this is your y. We're going to plot these ordered pairs and then we're going to connect them together. So we've got 1, 1. So 1, 1 would be over 1 and up 1. We've got 0, 3. So that's at 0 and up 1, 2, 3. And then we've got our last point, which is at -2, positive 7. So there's 3, 4, 5, 6, 7. So it's going to be right about there at -2, positive 7. Now, when we connect them together, very, very important, they should make a straight line. If they do not make a straight line, then we made a mistake. If this point would have been like here, you know you made a mistake. When we connect them together, they're always in this section and this course as well, going to be a straight line. Now, in college algebra, you'll have different ones, but in this course and intermediate, when we connect them together, they make a straight line. And that's what your graph should look like. Okay. Let's do a couple more, because I want to talk about vertical, and I want to talk about horizontal lines. So we're going to, again, complete the ordered pairs and graph. And let's give you one where you only have one variable. Let's say x equals 5. So this one's going to be a little bit different from the others. The other two that we have done have been diagonal lines. This one is not. This one's going to be a vertical line. Now, what is this saying? We only have one variable. Okay, and what is this saying? That x is always going to be what? 5. So does it matter what value of y I put in here? No, because what is the value of x every single time? 5. So all of these blanks should be what? 5s, because it doesn't matter what the x value, what the y value is, because x is what? 5. Now, what do our ordered pairs look like? Well, they're going to be 5, 4. They're going to be 5, 2. And then we've got 5, -1. And when we connect them together, what is my picture going to look like? When I connect these all together, it's no longer going to be a diagonal line. It's going to be a vertical line. And so let's connect these dots together. So 5, 4, so that's over 5, right? And up 4. So that's right about there. 5, 4. Then we've got 5, 2. So that's right there. And then we've got 5, -1, which is right here. And when we connect them together, notice it's a different type of line. It's no longer a diagonal line. What is it now? Yep, should be a vertical line, just like this. And in a later section, we'll learn that x lines are vertical, y lines are horizontal. But that's a later section. So when I connect them together, it gives you a vertical line like that. And that was when you only had an x value. Now, what about if we only have a y value? If an x value was a vertical line, right, then a y line is going to be what? Horizontal. Okay, that's what we need to kind of remember, and we'll talk more about this later. When you have two variables, x and y both, it's always going to be a diagonal line. When you only have an x line, x part, it's vertical. And when you only have a y part, it's horizontal. But we are going to cover that in more detail in another section when we talk about the slope. So let's do one more of these. And again, we're going to graph and complete the table, or the ordered pairs. And I'm going to give you a y value. Let's say we have y equals -2. And I'm going to plug in some x values. And let's say we have -4, 1, and 2. Okay, so if I'm looking at this table and my equation, well, what do we know here? Okay, we know that y is always, no matter what, going to be -2. So does it matter what the x value is? No, because what is y always going to be? -2. So what's going to go in all of the blanks here? So each one of these is going to have a -2 in it. Why? Because x doesn't matter. X could be whatever value it wants to be, but y is stuck at what? -2 every single time. So all of these are going to be -2's. Now, if it's written as a table, what I usually like to do is I like to rewrite them as ordered pairs. So as ordered pairs, we would have -4, -2. We're going to have 1, -2. And we're going to have 2, -2. And we just talked about this a moment ago, but this should make a horizontal line. And let's plot our points, connect them together, and make our horizontal line. So first off, we've got -4, -2. So that's going to be back 4. Right? Watch it, x always goes first. That's the left and the right. Y is the second, so it's going down 2. So -4, -2. We then also have +1, -2. So that's right here. And then we also have +2, -2, which is right there. So what do we have? We have 3 different points. And we can now connect these 3 different points together. And that's going to make, in this case, a horizontal line. And again, we'll talk more about the equations in a later section. Right now, we're just learning about ordered pairs and how to work with equations. So that is all there is in Chapter 3, Section 1. There's not a lot in this section. We're now going to move on, and we're going to look at 3.2. And 3.2 is similar, but we're going to talk about how to graph some of these equations when I don't give you any points. We're also going to talk about the intercepts and what they are. So we're now going to look at 3.2. And these sections overlap a lot. So what you see in Chapter 3, Section 1 is going to be similar to 3.2. Only difference is they have you graph a lot in 3.2, but they don't give you points. You have to find your own points. Now, whenever we graph a line, we need 2 distinct points. And sometimes those points are the intercepts. And let's talk about what the intercepts are. I'm going to do this graphically so you can understand what intercepts actually are. I'm going to draw a line, and I'm going to label the intercepts. Okay, so I'm going to connect these together. And we'll talk about what the intercepts are graphically. Let me connect these together here. Okay, so we've got a line that looks like this. So this line has intercepts. Now, what intercepts are is where they cross either the x-axis or where they cross the y-axis. And I labeled them x and y so that you can see. Now, this one right here, where it crosses the x-axis, well, this is going to be our x-intercept. Let's see, does that pen show up? Yeah, makes a little bit different color there. Okay, so that's going to be our x-intercept. And what would this be as an ordered pair? I want you to label it as an ordered pair. Well, remember, what value goes first? The x. And the x is the left and the right part. So what did we do? At this point, we went over what? Over 5 units. And we're at 0. So my x-intercept would be at 5, comma what? 0. Why is it the x-intercept? Because it crosses the what? X-axis, right? Now, what about the y-intercept? Well, it would be up here. And if we look at the y-intercept as an ordered pair, what would that one be? Well, are we going left or right any? No, it's right here at 0. And how many units are we going up? 3. So my y-intercepts would be, or my y-intercept would be what? 0, comma 3. Is everyone okay with that? That is graphically what the intercepts are. You can graph a line by finding the intercepts. Sure. Okay, the y-intercept, now remember, this is my x part here, and these are positive values, and this is negative. Right here is the 0. So I'm not going left or right any, am I? I'm at 0 on the left and right. And how many units am I going up? 3. So the left and right part is the x, and that goes first. Well, I'm right here at 0. And how many units am I going up? 3. So that's why this one is at 0, comma 3. Now, what about the x-intercept? That one is going forward 5 units. And are we going up or down any? No. So it's at 0. Does that make sense now? Okay. So those graphically are what the intercepts are. And intercepts are where they cross the axes. In some cases, you may only have one intercept. So let's look at one where we only have one intercept. Diagonal lines have 2 intercepts, but vertical and horizontal, well, they only have 1. So I'm going to give you a line, and we're going to talk again about the intercepts here. So here's a vertical line. Now, for this vertical line, again, we are looking at where it crosses the x and where it crosses the y-axis. So, let's first talk about our x-intercept. So what would the x-intercept be? As an ordered pair. Now, it has to be written as an ordered pair. It's right here. And it is not just 4. As an ordered pair, intercepts have to be ordered pairs. And as an ordered pair, that would be what? 4, 0 or 0, 4? Which way? Okay. 4 comma, 0. Not just 4. It has to be written as an ordered pair. Now, what about the y-intercept? This line is a vertical line, and does it ever cross the y-axis over here? So it has no y-intercept. And why does it have no y-intercept? It never crosses the y-axis. So it's never going to cross the y-axis. Okay, and why does it not have a y-intercept? Because to have a y-intercept, it must do what? Okay, it must cross the y-axis. So for some of these now, I'm not going to give you ordered pairs. You're going to have to find the intercepts yourself, and you're going to have to graph the line. Okay, now let's go back. Well, we're looking at, we can look at either one. We'll look at this one. Okay, and let's talk about the x-intercept. Now, when I talked about the x-intercept, what did you notice? The x-intercept, we had a value for the x, but y was going to be what? 0. Okay, and if we go back up and we look at this one has an x-intercept and a y-intercept. Now, the y-intercept, what did it have? 0 for the x, and it had a number for the y value, right? X-intercept means we have an x value and y is 0. So I want you to find the intercepts. So we're going to have to complete ordered pairs. And when we complete them, here's what they look like. So the x-intercept, we'll do it first. So the x-intercept is going to be some value that we've got to find, comma 0. The y-intercept is going to be an x value of 0 and some value of y that we have to find. You see why we've got two ordered pairs there. So the x-intercept, and they're always like this, the x-intercept is some number, y is going to be 0. The y-intercept is x value is 0, and we have to find the y value. Now, we have done these before. Right? We just did this a moment ago. We plug the values in and we find the missing part. So let's do the x-intercept first. And for the x-intercept, we're going to plug in y equals 0. And if I plug in y equals 0, then that gives you 0 equals a minus 2x plus 1, right? Okay. And we can solve this and we can find the missing part. So let's do that. And again, these do not always come out to be whole numbers. Many times they're whole numbers, but not always. So we subtract our 1 off. So minus 1 equals a minus 2x. And how do we finish this out? We divide by our negative 2. And what do we know about a negative over a negative? So that's going to come out to be a positive 1/2 here. We just plugged our value in. That's all we did, was we just simply plugged in our value. Okay, what about the other one? What about the y-intercept? To get the y-intercept, what are we going to do? To get the y-intercept, we plug in x equals 0. And if we plug in x equals 0, it's actually easier. If we plug in x equals 0, we have y equals now a minus 2 times 0 plus 1. Well, minus 2 times 0 is what? 0. And 0 plus 1 is just a 1. So y would be now what? 1. Okay, because that piece is gone. Now, do we have two different points now? Yes. When we have our two different points, we can plot them and we can connect them together. In the next section, we'll learn how to graph these without having to make a table and use ordered pairs. But right now, we're just learning how to plot these points and connect them together. So I've got minus 1/2, comma 0, and I've got 0, comma 1. They're separate. What about my first one? Remember, this is a fraction, so what do? We just kind of guess as to where it's going to be at. A half. Well, what do we know about a half? Half is directly between 0 and what? 1. So a half, comma 0 is going to be right about there. And they don't have to be perfect graphs. These are just sketches, because if you wanted a perfect graph, you would use a computer or a graphing calculator. We're just learning how to plot these points. What about my other point? My other point is at 0 and up what? 1. Do we have two different points? Yes. We can now take these two separate points and we can connect them together and graph our line. So there they are. Now, look at it. You can definitely tell that these are intercepts, right? Okay, this one right here, which intercept is it going to be? It's going to be the x-intercept, isn't it? And why is it the x-intercept? Because it crosses the what? X-axis. This one up here is the y-intercept. And why is it the y-intercept? Because it crosses the y-axis. When I teach graphing, it's very visual, so I like to make sure we understand what it looks like. That way you're not just calculating through and running through things and don't understand it. We're going to look at one more, and then we'll take a break, come back, and finish up this section. So we're going to look at one more of these. Okay, now we need to find our intercepts. That means we've got two different points. And they're separate. Don't put them in one point. They are separate values. So, for the x-intercept, it's going to be blank, comma, 0. Because we're going to be plugging in y equals 0. For the y-intercept, it's the opposite. Think about what value you're looking for. Y. Where is y at? Here. So x has to be what? 0. See how I made the ordered pairs? Now if I plug my values in, let's see what happens. This one's a little bit different when we get our result. If I plug in x equals 0, or not x equals 0, y equals 0, because we'll do that one first, right? If I plug in y equals 0, because this is my y value, that gives you 0 equals 4x. We'll divide by our 4, and what does that give you? X is going to be now. If I plugged in 0 divided by my 4, x is also what? 0. It's double 0. Now what about the y value, the y-intercept? If I plug in x equals 0, what does that give you? That gives you the same 0, doesn't it? Because 4 times 0 is what? 0. So what do we know about the intercepts? They're the same, and they are both what? 0, 0. Now, can I use a ruler to connect a line with only one point? No. I need 2 points, right? Because I need to be able to have 2 points like this one. where I can connect them together and make a line. I only have 1 point. They're the same. The intercepts are the same, so I need another point. Whenever it comes out to be double zero, this is what you're going to have to do. The intercepts are both 0, 0. We need another point. Okay, we have to have at least 2 points to connect a line. So we need another point. So the point we're going to be using is this. We're going to find, we'll make an easy one, find 1 comma blank. So we need another point here. So we're going to have to find 1 for the x value, comma blank. That's going to give us 2 different points because all we need is 2 different points. So if they're double 0, then we're just going to plug in 1, and we're going to find the y value, and that's going to give us 2 different points. So let's now go ahead and plug this in. Remember, this is your x value here. And we're going to plug in x equals 1. And remember, our equation was y equals 4x, so we plug that in. So y equals 4 times 1. And that gives you y now equals what? 4. So that gives me another ordered pair, doesn't it? Is that going to be enough to graph the line? Yes, because what must you have? 2 separate points. Okay, so let's go ahead and graph this one. And where are our intercepts both at? 0, 0. That's the origin. That's our first point. And that is the x and the y intercept. Now, where's my next point? My next point is over 1 and up 1, 2, 3, 4. So it's going to be right about there at 1, 4. Do I have enough to connect them together now? Yep, I do, because I can take a ruler, straight edge, whatever you have, line them up, and you can now draw your line. And there it is. Okay. Let's take a short break. We'll come back, and we'll look at vertical and horizontal lines. And then that'll finish up this section, and we'll start the next one. There's not a lot in this section. It's all